What I'm going to do is show you how a profile is expressed in a structure definition. And actually it's a 101, so I'm going to keep it easy. So, not assuming you know anything about how structure definition, the resource, what it actually looks like, that's what I'm going to talk about. I'm going to show examples in XML, not in JSON, so I hope you can bear with me if you're a JSON guy. So we're going to keep it slow, I hope. Well, that will work. And that's going to be a little bit hard for me because structure definition is a resource in FHIR that I've been intimately involved with. So I'm dreaming, living, breathing structure definition. So there might be things that I'm just skipping over that I think are totally obvious, which aren't. So just feel free to put up your hand and say, oh, hold on a moment. This is a 101, so I want you to understand the basics of structure definition. Okay? You can interrupt. Put up your hand. And if I don't see you, just yell. Right, let's see if this works. Oh, this was where let's see if I'm typing. Would that work? What? Well, I don't. First, adjust the arm. Yeah. I guess this should work. Yeah. That's good for the video. People at home too. Okay. But as you know, I'm normally walking around, so let's do it like this. Here we go. When I type, I'll put it back. So my name is Ewout Kramer. I work at a company called FHIR, Health Informatics. I hope you have heard the name a few times before now. And I am a developer, software developer, but I'm also part of the FHIR core team. And we've divided labor up a little bit. Well, in the core team. It's not really true. Graham does everything, we know that. But my part of the spec that I'm most intimate with is structure definition and everything about conformance resources. So I'll give you a bit of context about structure definition. The name is, I mentioned it a few times already, structure definition is a resource. And structure definition describes structure of everything that's in the spec. So patient resource or any of those resources are described using structure definition. So it's really metadata. So if you profile, for example, patient, you're using structure definition as well. And structure definition is part of a larger picture. I think Michel has shown this picture as well. This is from the spec. Structure definitions can be referenced by a capability statement of a server, for example, saying, hey, I'm a server, this is my capability statement, and the resources in my system are actually described by these structure definitions. So capability statement can point to structure definition in that way. Capability statement can describe the messages supported by a system, the documents. It's all done using structure definition. So the capability statement of a certain server might point to structure definition. As well, there's something like implementation guide. And an implementation guide is a bunch of text around structure definitions, value text that is human readable. So implementation guide as well points to structure definition. But I think by far the most important for us today is that any resource may point to structure definition and say, hey, I'm conforming to that structure definition. We might want to check that out. It's, it's just a claim. So if you write a patient instance, then somewhere in the top on meta you can say, I'm conforming to that in that profile. You're pointing to a structure definition. And finally, of course, any server or any client can say, I have an instance here of a certain FHIR resource, and I have a structure definition, and I want to validate whether the one matches the other. So that's the context for using structure definition. So structure definition doesn't contain any patient information itself, it just describes all the resources in the specification, and also it can describe your version when you're profiling the resources in the specification. So again, structure definition is a resource, which means you can send it across. Which means that most generic FHIR servers will have a structure definition endpoint, just like they have an organization endpoint or a patient endpoint. You might say, what's the use of that? Well, it's interesting because that means that you can use the same technology that you're using to transfer patient information. Once you know how to do that, you can transfer structure definitions from one server to the other, from a client to a server and so on. You can store it in registries because it's a resource anyway. And once it's in a registry, you could just use the regular FHIR API to get those structured definitions back out. And you have a library of structured definitions. So structured definition describes the definition, which is both structured, so that patient has a name, has family, and so on, the hierarchical structure, and the validation rules. These might be expressed as values, set bindings, but also FHIR path constraints and so on. I'm assuming you know a little bit about that. There have been lots of tutorials showing you that. But I need to zoom in a little bit. Structure definitions, the use of structure definition, I actually fall in two categories. One is defining a type. So the core specification defines from nothing what patient looks like. So in this case, structure definition is much like a class in any programming language. You start by class name, and then you specify the fields. That's what structure definition can do when you're defining a new type, which is slightly different from when you use structure definition to profile. And if you profile, you take an existing type, and then you constrain it down to your use case. So one use of structure definition is defining stuff, which means creating new attributes and defining new elements and logical models. And the other use is, given an already existing structure definition or existing type, constraining it back in. And that, the last category, is what we call profiles. But also extensions are defined using structure definition. And then if I have time enough to show you, I will show you how extensions are done in structure definition. So these structure definitions are available for everyone to see for the whole specification. And in fact, if you go to the FHIR specification, you can find them on the page for each resource. And it's under the, well, either the pretty UML picture or the structured tree in the spec. Let me just show it. HL7.org/FHIR. Let's pick, not patient again. Vision claim or something like this. Something we've seen before, it doesn't really matter. Okay. I could even show you structure definition, but showing you structure definition, defining structure definition is going to be a little bit confusing in the morning, so let's not do that. I know the philosophical people here will now be wondering, well, how did they write the first structure definition? Yeah, well, whatever. So here's organization, and then here it says master definition. Doesn't really say structure definition or whatever. Master definition, and it's in XML and JSON. And so I said I'm doing XML today, but let's do JSON for now, just to to keep the JSON people happy as well. And well, I'll be talking about all of this, so I'm showing you just you can get it. This is the structure definition describing organization. Getting them one by one is nice, but you can get them all at the same time as easily, because there are download links in the spec. HL7.org downloads, and there you find a zip which has all the definitions in the spec. And if you download the validator, for example, the Java one or mine, it will have this stuff in it, and it's packaged in files like profiles types, profiles resources, and they contain bundles with all these resources. So you have all the structure bundles full of structure definitions defining each and every type. Of course, you can find them on simplify.net as well. These files are huge, like megabytes and megabytes of data, because they have the definitions of everything, every single byte that's on a page in the specifications in the structure definition there as well, every bit of description of every single field. It's all there. You could regenerate the specification from these structure definitions, mostly. So what's in the structure definition? A lot of JSON. We've seen that. That's because, well, but the basic structure is easy. It's kind of a header that has the metadata about who wrote this structure definition and what's in it. So a version the name of the thing, the publisher, content, lots of metadata like that, but also yeah, the FHIR type you're constraining, or whether you're based on another profile. That's all in there. But the most important, the meat of the matter, the actual description of the type you're describing or what you're doing to constrain is in these bits here, snapshot and differential. I'm going to talk a little bit about both. But basically, the differential contains all the changes compared to the base. So if you're using structure definition, as I said, structure definition can be used for two things. I'm talking about constraining something now. So say you have a patient and we're looking at the structure definition for Dutch patient or Norwegian patient or whatever. You will find in differential exactly those changes that you've made, those constraints you've added on top of the base patient. And snapshot will contain everything. So it will contain the elements you did not change, plus the element that you did change. So snapshots usually is pretty huge, because it contains all the information from the base, plus your changes. So here's an actual this is a readable structure definition. Why is this smaller than the one I was just showing you in JSON? It's not more readable because it's XML. It's more readable because I have created a structure definition here which contains only the differential. So this is an example of what I was going to say. We have a structure definition, and I've named it here, the unique URL, example.org structure definition patient IK. I was supposed to type EK for my name, I think, but it doesn't matter. Patient IK. And this is the most important piece of information in the structure definition, because that identifies the structure definition. As I showed you in that context picture when I started this, other resources are referring to this structure definition, and how will they refer to it? They do this by this URL. So this better be unique. So you would usually put your organization name there. Then the next interesting bit of information is type and base definition. And just says, I'm a constraint on patient, and actually the base definition is here at hl7.org FHIR structure definition / patient. This means already, you see a reference here. If I would open the structure definition for patient, this would start with URL, this URL. Now here you would say, why this is double? You're already stating that this constrains patient, so why repeat this again? And that's because people may go on and say, well, your structure definition is nice, but I have a few more constraints on them. So you can have a structure definition that constrains this structure definition. So in that case, we're still looking at constrained patient, but base definition will actually be my URL. So if someone defines the structure definition based on this, I will appear here as the base. And then finally, the differential. And this is a very, very simple constraint. I'm saying patient.identifier.use, I'm constraining it to 0. So saying don't use identifier.use. Questions? Okay. I'm lazy, so the way I did this was I opened up Forge. I created my so here we go. Here we can see that I made a mistake here. I created my my structure definition. I just limited use here to 0, and then here in the XML tab, I can take a look at what's happening behind the scenes. So here you have it, exactly the thing, well, not exactly the thing that I was showing you. There's some extras here. And I copied and pasted to give me a head start. But actually, from this moment on, I could as well go on and edit this stuff by hand if I really wanted. Forge is easier, but for today, we're going to keep it simple. So most of the things I can do by hand now. This is the one-on-one. You click constrain patient.use here to 0 to 0. This is what I did. And then in the XML, So as you can see, here, patient identifier.use, nothing is repeated that I did not change. And also, I've just changed the maximum to 0. The minimum was unchanged. Because the normal in patient identifier.use is 0 to 1. And I've changed the maximum to 0. So even the fact that the minimum is 1 does not appear in differential. It's really terse. It's really just containing your changes. The differential. Now, if I create a snapshot out of this, first, my initial differential was 1K. Well, actually under that, I think. And when I created a snapshot, it turned out to be 490. And that's because it gets everything that's in patient, plus these few changes. And you can see here, it has patient, it has everything that's in patient, and especially it has patient.identifier. And if we go even deeper, patient.identifier.use, we can see that our max appears here, well hidden in 490K of data that we did not change. But it's here, in the red box. That's our single change. We can even see, as a service to us, that the base used to be 0 to 1. It's really useful to have that if you have a tool, so you'll be able to show what you as an author changed. You can just compare what was in the base and what's now here. So it's really elaborate. As you can see, it has all constraints for each element. Not only the max that we did, but it now has min, all the documentation, it has the base, it has the type, and there's a whole list of things there. So the snapshot is big. And one thing that you can see here as well, now we have a whole list of these things. So this is inside snapshot, see? We were looking at differential before, this is snapshot, is that actually the way this works is that we're listing, patient is a hierarchical structure, but we're listing it as, we turn it into a flat list by this path actually, patient.identifier.use. So you can reconstruct the hierarchy, but the XML itself, and nor is the JSON, is actually hierarchic. It's just a flat list, and the path shows you the hierarchy for the structure. Questions so far? Yeah.
When do you use the snapshots and when do you use the other ones?
When do you use the snapshot and when do you use the differential? That slide is coming up. So this was the base. I zoomed back and I went into the structure definition for patient. So this is what I based it on. And you can see that the original patient had a lot of stuff above here, and then it had patient.identifier and patient.active and so on. We can see now that the snapshot actually contains way more than the base. Because the original patient said patient.identifier repeats and is of type identifier, and that's all it says about patient.identifier. However, when I created a differential on top of this that started to walk into patient.identifier.use, when I create a snapshot of my derived stuff from here, it actually moved all of that. See, patient.identifier is from the base, but everything here is not from the base patient, it comes from the identifier type. So what snapshot generation did here was take patient.identifier, see, hey, hold on, this is identifier. Let's go to the structure definition for identifier. Include the whole identifier here, so I can finally include the fact that we have constrained patient.identifier.use to 0. So a snapshot might be way bigger than the base, because as soon as you constrain something, it will include all its siblings here to have the context of the thing you are constraining. Luckily, you don't have to do this by hand. There's .NET and Java library to do all that. It's pretty ingenious code. Michel has written most of it. I'm happy he did, because this is hard. If you do this by hand, you will do it wrong. So something to be done with an algorithmic and a library and API to do this for you. So, but this walking in is essential for you to understand what you're looking at if you're looking at snapshots. You don't have to make snapshots yourself, but if you're looking at it, it's good to know why this is there. Yes, question?
Are only, let's see, is it only the constraints that are walked into, or is everything walked into in the snapshot?
In the snapshot, only the constraints are walked into. So, patient.active, we did not walk into patient.active. So in the snapshot, it will just still say patient.active, type code is Boolean, and it won't go in, it won't walk in there, only if the constraint does. Very good question. Yeah, just so not to insult your intelligence, I'm gonna make this one step more difficult, just to, to see how sharp you are. Another differential here. I've changed the differential slightly. Here is our original patient.identifier.use max value is 0, but I added another thing. Actually, I put another constraint on the parent, patient.identifier. And what I said is, patient.identifier is not just identifier as we know and love it from the spec. No, it's the identifier as profiled by identifier NL. So what I'm saying here is, well, what am I saying? I'm combining two things. One is, I'm changing the identifier to conform to the Dutch identifier, plus I don't like the fact that the Dutch identifier, which is pretty generic, still allows use, so I want to constrain out use. So this now we have a combined set of constraints of the Dutch patient NL, Dutch identifier NL, plus this one. So the quiz question, of course, what will the snapshot contain? Think about it for a second. This has nothing to do with yesterday evening, no. Good, I've got a, hello? Yes. I've got a schematic representation here. I really miss my whiteboard here. So, on top we had patient, the base patient. And patient, as we saw, even in the base, only has patient.identifier is an identifier. Next, I created patient EK, or IK, which then said, I'm changing two things. Patient.identifier is now identifier NL, and I have a constraint on identifier.use, patient.identifier.use actually. And maybe, I didn't show you, but maybe the structure definition for identifier NL has constraints on identifier.use and identifier.system. What is the total sum of this? What will happen? So what the snapshot generator will do is go from the top first here, look at patient.identifier and say, oh, good, it's an identifier. Then it sees its identifier NL. So the snapshot will contain, because we're walking into identifier using the identifier system, the snapshot will contain the base information from identifier NL. So if the snapshot will contain the constraints or on identifier use and identifier.system, and then on top of that, identifier.use. So the total picture has everything for patient, it has identifier.system from identifier NL structure definition, and it has identifier.use, which overrided this one too. And that's what you'll see in the snapshot. So this way, you don't have to go out and define first your own structure definition on this and then refer to it. No, you can just refer to it if it's basically okay and have extra constraints on it. Now, if you got that, you're pretty all right. You're going to be all right today. Okay.
So I'm not understanding something here. So you're saying you're changing the type of it and then saying you don't want it?
So what I'm saying here is, yes, kind of changing the type of it, but identifier NL, of course, is a neat subset of its constraint of an own identifier. So I'm not really changing the type, I'm just saying I have some additional constraints. But other than that, I'm saying I'm loving most of what is in identifier and NL. For example, I really like the fact that I did this with system. This might, for example, refer to, if we're talking patient identification, it might be talking about our national patient identifier. So I like everything, and there might be way more here, but I want to make my own local changes in this profile. So I'm copying 90% of what the Dutch did, but I'm just changing this little bit, which still makes me compatible with this one.
So you're actually changing the constraint. It's not like they're combined now.
Yes, I'm actually overriding the constraint. That's true. They're not combined. Identifier of use here is totally overridden by this identifier of use.
What? Sorry.
Okay.
I have one more question.
Yeah.
What happens if you use the constraints in the identifier NL,
Yeah.
and then undo that, one of the constraints, with the identifier.use?
Ah.
Is that possible?
What should happen is that the tooling, hopefully either your authoring tooling or the snapshot generator will say, whoa, you can't do that. You know, you said you're compliant to identifier NL, but you're undoing, so you're not compatible with it anymore. But I'm going to promise you that the tooling isn't, I think, at this moment, not yet that that mature that it does that, but it should. We had a birds of a feather about this, where you want to actually state that you're creating a new identifier, but you want to be compatible with identifier Belgium, Netherlands, Germany, UK. You know, give me the smallest, the subset that actually fits in all of them. And we should be able to do that at some later moment. Now, to your question, why is snapshot at all? Why bother with all of this? Snapshot, so we derive it from a base. Here we go. We have the core patient apply a differential, but it might well be that someone has done constraints on top of that, as we've seen, and so on and so on and so on. So if I just had a differential and I want to, for example, render the end result or run validation on top of it, I would have to go out first. So I want to render or validate the constraints that are in here. I'm saying, oh, this is based on something. I have to go out on the internet or wherever to get that differential. I have to get out again to get that differential and then recombine them every single time I'm doing validation. Maybe I don't even have access to the stuff that my things are based on. Maybe I only had access to it at authoring time. So the snapshot is really useful in the sense that when the author is creating this structure definition, its constraints, he had access to the base. And that's all included in the end. It's kind of compiling your structure definition into something that has everything that you need to validate or render or whatever. Validate, yeah. So that's basically why we do this. So it's not really necessary. There's nothing in spec says you have to ship it. In fact, if you ship a structure definition with just a differential to, for example, the registry to simplifier, it will do this work for you based on what it has in its database. So you don't have to do it. But it's really useful in the end to have it before you start validating or rendering. But the alternative, obviously, is if you're sure that you're complete, you can just pack with your app all the differentials, and then when the app is starting up, it can just create whatever it needs. Most of the libraries that we have now will allow you to do all this and combinations of that. So what we've seen is that differentials and snapshots are huge collections of things that are element definitions. Element definitions are the base thing in the spec. It's not a resource, huh? It's contained in structure definition. So where do we go? HL7.org FHIR. As soon as I press S, it will have structure definition. Yes. My browser learns what I need. So this is all that metadata, and on the bottom here, we see differential and snapshot, and they are of type element definition. So element definition really contains the meat of the matter. This is a data type, and my page down now is a full screen. Yeah, FN, oops. Yeah, and here's element definition. So this is element definition has a min and max that we've been using, but it has way more. I think I listed that in my presentation. The most important ones. Path we've seen, patient of identified use. It has textual representation actually in Markdown that describe what it is. Min-max cardinalities, fixed pattern, type ref, and binding. Binding is about coded types, invariants here formulated in FHIR path. All of the real definitional stuff is in element definition. Let's skip this one now, I think. I want to go into a few details here about how things are represented in structure definition, and actually in element definition. Jack. 10 more minutes of fun. Good. These are the few exceptions. Normally we've seen patient.identifier, simple is represented as patient.identifier. But how is observational value X done? If you look in the spec, it looks like this. There's a choice of types there. So there's not a one-on-one here between the element name, or that's at least what this suggests, the element name and the element definition in the structure definition. Another case, it's the second kind of case that I'm going to look with you at, is this. Reference. So performer, observational performer, is a reference to either a practitioner, a patient, an organization, or a related person. What does that look like in structure definition? So to answer the first question, this is straight from the spec. Observation value X. And now we see the type repeats. So before we had type code as identifier, but here for observational value X, we have type quantity, type code of concept, type string, type range, type ratio, and so on. So this is all available under observational value X. And you see the X at the end here? That means already this is a choice type, and here are the choices. And if for your use case, if you're constraining this, so say in observation NL, or observation quantity, an observation that can only have quantities, we can constrain this by having a differential that leaves out the types we don't need. So I have that here. Here I have constrained observational value to just be able to receive quantity, ratio, and period. So this whole list is dumped down, constrained to only 3 types now. And to spice this up a little bit, I've shown you as well, this is not just any quantity, no, this is a weight quantity. And it's not just any ratio, no, it's a weight ratio, or it's a period. So that's how this gets represented. In fact, I had constrained value quantity even more to weight quantity, and so on. Okay. What about these references? Reference of patient, reference of and so on. That's slightly different because these are all references. Here we have different types, but a reference of A, B, C, and D, it's all a reference. So that in structure definition looks like this. Observational subject, again, a repeating type, but you can see that code is the same in all of them because they're all references. But these ones refer to device and location, and this one refers to patient NL. So this is actually saying observational subject can contain a reference that points to any patient as long as it conforms to patient NL. And that's why this is called target profile. I mean, here in the box we have profile, which is a profile here on this ratio. This is a weight ratio. But here we're doing references, and you're actually saying this references targets a resource that can only conform to patient NL or to device or location. Yeah. This will change in R4, by the way. We will have one code reference and then a repeating field target profile. It makes for a nicer display. Now, nothing changes semantically, but instead of repeating reference, we can then repeat target profile right here at this spot. Ha! Quiz. So, what does this mean? Observation.subject, we've already seen it. Now, it's still a reference. There's still a target profile on it, pointing to patient NL, but now there's also a profile on it. So this has both profile and target profile. This is to thoroughly confuse you. What is this doing? Anyone? The answer is 5 minutes. Oh, no. I have 5 minutes. There we go. So, just a little hint. This is what the data type reference looks like. Data type self reference has a reference, which is URL, but also identifier and display. So maybe you start to get an idea what this is doing. This is saying observation.subject can only point to stuff that conforms to patient in L. But the reference itself, reference with display, always needs to have the display. So you're constraining both what the reference itself looks like in the observation, plus what that reference may point to at the same time. Target profile, profiles what the reference may point to, and profile, profiles what the reference as a type itself looks like. Just like human name or identifier. Just like we just constrained identifier and patient, we can constrain reference as well. It's not a common case. That's why this was new in STU3. We had just forgotten about it in STU3, in STU2, but we added this in STU3. So to step back a little bit, let's take a look at structure definition. And I told you about canonical URLs. I just want to zoom out a little bit what we've seen so far. We have seen that the structure definition has a canonical URL and contains lots and lots of element definitions with the meat of the matter. Every structure definition has in its top metadata a reference to its base definition, in this case patient, and the type refs that we've just looked at using target profile or profile can point to yet other structure definitions. This is all using the canonical URLs. That first URL bit on top of the structure definition. That's why this is so important to get it right and to get it unique. Because a registry like Simplifier would get totally confused if that's not unique. What are you pointing at actually? Oh, and there's of course the binding value set which references value sets. That's not. All of them use the canonical URL. Good. Now I have just a little bit of time to at least present you maybe one surprising fact. And it's how do we define extensions? Surprisingly, maybe, extensions are defined using structure definitions. There is an extension data type in the FHIR specification. It's very simple. It has a URL and it has a value. You've seen it in instances everywhere, right? Patient and then extension, 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 extension. Extension looks like URL and then just value boolean, value datetime, whatever. Stacks of extensions. And now to define an extension, so if I want to say hair color extension or whatever, birth time extension, I'm actually taking the base extension data type and constraining the URL and the value. Here I have an example of, well, very boringly called extension, my extension. And what I'm doing here, so I've shown you differential here. So there's a whole lot of structure definition on top of it, saying that this example, this extension that we're looking at is called example.log/FHIR /structure definition /my extension. And then let's take a look at the differential. First, it says extension max 0. That means this extension is a simple extension. It can't contain nested extensions. This picture doesn't actually show you, but there's another link here from extension to extension. This is a simple extension. There's no nested extensions here. Then I'm constraining extension URL exactly to my canonical URL. That's the trick. By creating a constrained extension with this, the only way to create an instance, to actually have this extension in my instance, is if the URL is exactly such and such. And finally, I'm saying, oh, by the way, my extension of value x here has all the types, it's a choice. So in the base definition of extension, I have a really long type of type, type. I'm constraining it to just Boolean. Min, max to 1. So this is an extension with always this in the URL and a Boolean value. And this way I have defined what this extension looks like. So we defined an extension by constraining the extension data type. And so if you would go out to Forge and say new extension and start doing things, and I don't have time for that, unfortunately, good, great. You would see that Forge will do all of this for you. But don't be surprised in that case when you look at the XML. Now you know what's going on. I'm not going to talk about slices. I didn't want to, so that's good. So I arrive at questions. Any more questions? Yes?
In the canonical URLs, there's never any reference, there's simply a reference to the FHIR version. So is that supposed to be sorted in a different way? So if you publish a new version of FHIR, the canonical references will now reference the new definitions?
Yes, this is another very good question. I think we've made a mistake there, but bear with me. We had a discussion about this in the Birds of a Feather. The question was, so in the STU2 and the STU1, you had a canonical URL, structure definition / patient. But now you upgrade to 2 and 3, and this canonical URL remains exactly the same. And the problem is there as well, if you just changed patient or you do whatever to it. You could definitely say that between STU3 and STU2 we changed patient, yet we did not change the canonical URL. This is a nasty problem for a registry, because if you support all of those versions, you'll have 3 or 4 with the same canonical URL. The idea was, when we did this, that this was only draft. So in the end, it wouldn't matter anymore. There would be the one normative patient, and that would be the moment that the canonical was actually starting to be used. This is obviously not the case. You know, in real world, there will be the STU2 systems for a very, very long time. There will be STU3 systems for even longer, and we have a definite problem here. So we had a Birds of a Feather about this on Wednesday evening, about what to do with it. We can't fix that anymore for the base types. That's not something we'll do anymore. But we are going to think about, do you really have to put the version number always in the canonical URL? Is that really necessary? All the way down to a minor version number, or just a major version number? On top of that, structure definition itself, I don't know if you watched closely, has a version indication as well.
Yeah.
And even worse, we've described a way to turn a reference to a structure definition, so if one structure definition is referring to another one, with a pipe behind it to refer to a certain version of a structure definition. And if the pipe is not there, we're suggesting it's the newest one. But what's the newest one? The newest one you have available? The newest one that's available anywhere? I think we seriously messed up there. So the Birds of a Feather Wednesday evening, I think we've said to each other, okay, we messed up. We need something new. So that's a good question. And it hurts, but I don't have a definite answer to that. All right, thank you for your attention.